Right now, you feel completely stationary, but you're currently spinning on Earth's axis at roughly 1,600 kilometers per hour. At the exact same time, you are hurtling around the sun at tens of thousands of kilometers per hour. It doesn't stop there. Our entire solar system is whipping around the center of the Milky Way galaxy at over 800,000 kilometers per hour. This is the baseline of cosmic mechanics. Everything spins and everything orbits. But in the 1970s, astronomers measuring the light from distant galaxies found a glitch in this predictable system. The universe is expanding, meaning galaxies should be drifting apart evenly. Instead, the Milky Way, along with our neighboring galaxies, is ripping through space at an extra 600 kilometers per second in one very specific direction. To put that speed in perspective, the distance from the Earth to the Moon is roughly 384,000 kilometers. Traveling at 600 kilometers per second, you would cross that entire terrifying void in about an hour and a half. A hidden massive force is dragging the Milky Way off its trajectory, pulling us away from the uniform expansion of the rest of space. Scientists calculated the mass required to generate a gravitational pull of this magnitude. It equaled the weight of tens of thousands of massive galaxies combined into one single region. They gave this unseen behemoth a name, the Great Attractor. So why couldn't we just point a telescope at it and see what was pulling us? Because by pure cosmic coincidence, the Great Attractor is located perfectly behind the dense center of our own Milky Way. Astronomers call this totally blocked region the zone of avoidance. Imagine standing in the middle of a dense downtown metropolis. You know there is a massive mountain range out there somewhere, but you absolutely cannot see it through the skyscrapers. When we try to look toward the Great Attractor, billions of stars, thick gas, and dust perfectly block visible light from passing through. We are caught in a gravitational freefall. Our entire solar system, along with everything we have ever known, is plummeting through the dark toward a destination we are forbidden from seeing. Visible light was useless, so researchers spent decades scanning the sky using radio waves and X-rays, which can pierce through cosmic dust. By compiling this hidden data through the 1990s and into 2014, a team of astronomers finally mapped the space behind the veil. What they found rewrote our cosmic address. The Milky Way is one speck on the outskirts of the Laniakea Supercluster, a vast network of 100,000 galaxies, all caught in the same current, funneling down toward a central gravitational hub. That hub is the Great Attractor. But the map revealed something even larger. The Great Attractor is moving too. Laniakea, our entire home supercluster, is being dragged toward a neighboring structure hundreds of millions of light-years away, the Shapley Supercluster, a gravitational basin holding the mass of 10,000 Milky Ways. We are caught in a chain reaction of gravity. The Milky Way falls toward the Great Attractor, and the Great Attractor falls toward Shapley. We are squarely at the bottom of a cosmic food chain. With all this mass pulling us forward, it seems inevitable that we will eventually crash into Shapley. Will all these superclusters collide in one apocalyptic merge? No. In 1998, two separate teams of astronomers were studying distant exploding stars, known as supernovae. Because these explosions have a known consistent brightness, scientists use them as standard candles to calculate immense distances. They expected to find that the gravitational pull of all the matter in the universe was slowing down cosmic expansion. Instead, they found the exact opposite. The expansion of the universe is accelerating. Something invisible is actively stretching the empty space between galaxies, pushing them apart faster and faster every year. This is dark energy. It accounts for 68% of the total energy in the universe, effectively acting as the dominant force in the cosmos. This creates the ultimate cosmic tug-of-war. Gravity is desperately trying to pull galaxies together into massive clusters like Shapley, but dark energy is fighting back, expanding the space between those clusters at an accelerating rate. And dark energy is winning. Its outward push is already overwhelming the inward pull of the superclusters. We are traveling at hundreds of kilometers per second toward Shapley, but the space between us is growing faster than we can cross it. Our destination is a place we will never actually reach. If dark energy continues its steady, dominant push, scientists predict a scenario known as the Big Freeze. Over the next 100 trillion years, galaxies will drift so far apart that the night sky will go completely black. Stars will run out of fuel, and eventually, even the supermassive black holes will evaporate into nothing. A quiet, freezing end. But if dark energy begins to strengthen over time, we face the Big Rip. In this timeline, the acceleration becomes so violent that it overpowers gravity on a local level, shredding superclusters, ripping apart individual galaxies, stripping planets from their stars, and ultimately tearing apart the atomic bonds of matter itself. There is a third possibility. If dark energy somehow weakens, gravity takes the final victory in the Big Crunch. Trillions of galaxies rush back toward each other, colliding and compressing, until the entire universe is crushed down into an infinitely hot, dense point, a singularity. Some theorists believe this could even spark a brand new Big Bang. Regardless of which force wins the final round, the universe as it exists right now is strictly temporary. The grand structures of reality are governed by immense, invisible mechanics operating entirely out of our control. When you look at the scale of this machinery, it is easy to feel entirely insignificant. If you scaled the Laniakea Supercluster down to the size of a football field, the Milky Way would be smaller than a single grain of sand. And on that microscopic grain of sand, there is you. The atoms in your body were forged billions of years ago in the cores of exploding supernovae. Carl Sagan noted that we are star stuff, the universe's own matter organized into a form that can observe itself. We are incredibly fragile, and our physical footprint is effectively zero. Yet, from this tiny rock, we have managed to peer through the galactic dust, map the invisible flow of millions of galaxies, and decode the fundamental forces expanding the cosmos. We are adrift in an accelerating, uncertain cosmic river. We are being pulled by gravity toward a place we will never reach, and pushed apart by an energy we cannot see. But the simple fact that we have the capacity to map the journey, to understand our own fate, makes humanity one of the most extraordinary phenomena in the universe.